Number 5 we have done. Let me talk about question number 6. What does sixth question say? Sixth question is, let me check. Now question number 6. Let's talk about it. Question 6 says, find the curved surface area, curved surface of solid generated by the revolution about the x-axis of the area bounded by x-axis of the parabola y square, okay, bounded by x-axis of the parabola y square equal to 4ax and the ordinate x equal to h. Okay, and the ordinate x equal to h. That is, limits are 0 to h here. That's the point we have to find out. Okay, therefore, okay, that is the point. So what is the parabola here? Y square equal to 4ax. This is question number 6. So here parabola is y square equal to 4ax. Okay, so about the x-axis we have to revolve it. Revolution about the x-axis of the area bounded by x-axis of the parabola y square equal to 4ax and the ordinate x equal to h. Alright, that is the point. This is the parabola which we have drawn like this. This is x-axis here. X equal to h is any point here. Let me take this is x equal to h ordinate at this point, and here it is. X-axis is this, between x-axis and this curve. This is O point. This is, let me take A point here. OA is the arc which is revolved about x-axis. Then the area is calculated. Okay. And between this x equal to 0 to h, we will take the limits and then the area. Okay, so this is equation of parabola is y is equal to 4ax. This is equation number 1. And here solution, let me find out. Okay, so should I take the marker here? Let me take this marker. Okay, let me replace the marker. Let's start with this. Okay, I have to clean it before, but let me clean it now. No problem. Okay, so even something is revolved here. Okay, so here, what is the equation here? So therefore, area of this sphere, again we have taken this P point, P and Q point here. The same thing we have to find out. Okay, and this is x equal to h here at this point. The x equal to h this point, at this point we have taken. Okay, so here, but in this case, is it something, what is it? Find the curved surface area of the solid generated by the revolution about the x-axis of the area bounded by x-axis of the parabola 4ax and the ordinate x equal to h. Not a problem. Okay, now let me find out the area. Therefore, area of the surface obtained or generated by revolving the parabola, that means OA about x-axis is given by, here limits are 0 to h, which is between x equal to h limits say in x-axis. So 0 to h we will take y into ds. Again ds we have to find out, and y is from there. So ds upon dx, we have to differentiate first question with respect to x. So differentiating first with respect to x, so we get here, what do we get? twice by d by dx equal to 4a. Therefore d by dx equal to 4a upon twice by, that means 2a upon y. Alright, therefore substituting this value here, but ds upon dx is equal to under root 1 plus dy dx whole square. That means square root 1 plus dy dx is this value, which is nothing but 4a square, squaring this 2 upon y square. Now y square is 4ax. Let me now substitute that value here. So substituting the value of y square in this equation, we will get ds upon dx as 1 plus this is 4a square upon 4ax. Y square is 4ax from first equation, from equation of the parabola, from first here. This we have obtained from first. So 4a cancelled out. 1a is left in the numerator. This is nothing but a plus x upon x is the value here. If I substitute the value of dx there and y is that value, it will be twice pi. Okay, and y is here from this equation 2 under root a into under root x. 2 under root ax, this square root of 4ax is 2 under root ax into ds. This is nothing but ds upon dx into dx. ds can be written ds upon dx into dx. ds upon dx is this value. We have to substitute that. 2 2s are 4. This is 4 pi here. Sorry, this is 4 pi here. This 2 taken out, 0 to h here, 0 to h here, into under root x only, under root a let me take out. This is square root a, and this is under root x only left over here. And in the value of ds upon dx, we have a plus x upon under root x. This is square root x. Square root x cancelled out. This is dx here. Therefore, integration of this is, therefore, area is obtained by integration of this is 4 pi under root a. Integration of under root a plus x is a plus x whole power 3 by 2 upon 3 by 2. Integration of under root a plus x is limits 0 to h. Therefore, this is nothing but 4 pi under root a into 2 by 3 into 2 upon 3. This 2 by 3 will come here. Now limits, if I substitute h, if I substitute, it will be a plus h whole power 3 by 2 minus a whole power 3 by 2. This is the value here. Okay, but h cannot be eliminated. So finally, this is 8 pi by 3. Okay, under root a, if I take common, this can also be resolved. Okay, because a plus h, if I open by binomial term, can be done in that way also. 8 pi. Okay, under root a and this a raised power 3 by 2 we can take out. That will be a square, then 8 pi a square upon 3 in bracket it will be 1 plus h upon a whole power 3 by 2 minus 1. This can be opened then. Okay, and this is the value here. We can just open this by 1 will be cancelled out, then h upon a whole power 1 only, h upon a plus h upon a whole square. In that way we will calculate, we will get the values upon factorial 2 and so on. That is the point. This is the answer here. A equal to this value. Okay, so that is the point here. A upon 3 we have taken out. Okay, this is the value here. This can also be resolved because 1 plus h upon a whole 3 by 2 can be opened by by 1 will solve, but only this is the value, 8 pi a square upon 3. Okay, so this is question number 6 we have done. And let me talk about question number 7. What does question number 7 say? Let me check it. Okay, now question 7 is of what kind? Let me clean it completely. Now question number 7 is of what kind? Let me check it. Okay, finish. Now question number 7, 6th question. This is 7 says prove that the surface of the prolate is spheroid. Prolate spheroid is formed by revolution of ellipse of eccentricity E about its major axis. Try to understand. The prolate spheroid is obtained by revolution of ellipse of about its axis, means x-axis, about its major axis in this case. So prolate spheroid is obtained by revolving ellipse about its major axis. That is the prolate spheroid. Okay, that is the definition of that. This is known as prolate spheroid, which is obtained by revolving ellipse about its major axis. That's the point. What's major axis is this? Okay, it means ellipse is this. Let me take this is the ellipse here. Now this ellipse or half of the ellipse from minus a to plus a, limits will be here. It is origin O, or this is vertex. This is major axis here. This is y-axis. This is x-axis. X-dash. Now here point is A0. This is ellipse x square upon a square, y square upon b square is equal to 1. Okay, this is the point here. Now this is major axis. Sorry, minor axis. This is major axis. This we have taken major axis. This is also A. This is minus A and 0. Here it is 0 and B. It is 0 and minus B. This is ellipse here. Ellipse are not properly drawn, but let me take this like this. Now it's okay. It is ellipse here. The point is, what does it say? So this ellipse is a revolve about its major axis. Then what is the surface area? That's it. So prove that the surface of the prolate spheroid formed by revolution of ellipse of eccentricity E. E is the eccentricity undoubtedly about its major axis is 2 into area of the ellipse. Now we know that area of the ellipse is pi into AB. This we know about area of the ellipse. Area of the ellipse, this is area, this is pi AB. It means this is the area 2 pi AB under root, answer is this. 2 into area of the ellipse means pi into AB, twice pi into AB. Within bracket this is under root 1 minus E square. E is the eccentricity of the ellipse plus sine inverse E upon E. Okay, in the denominator of sine inverse E is E, eccentricity. E is the eccentricity of the ellipse here. In case of eccentricity of the ellipse, we know that B square is equal to A square into 1 minus E square. This we have to use in this case. We know that B, which is the minor length of the minor axis, and A is the major axis length. This OA, this A point is here. This is B point, this is B dash point, this is A dash point. Okay, so OA is A, this is A. So in case of this ellipse where A and B are these, this is major axis, this is minor axis, then B square equal to A square into 1 minus E square. This is the relationship this we have to use here. Let me just calculate what is the area of this is spheroid. Question number 7, this is where the ellipse, let me take. The ellipse is x square upon a square plus y square upon b square is equal to 1. This is first equation. Okay, now question, this is solution we are finding out. So what is the area of this given? Let me take here P and Q. This is PQ on the ellipse here. So this is could be have taken, and ds is this length of the arc length. Okay, arc length is ds. So what is the area of this? Let me first write that. Area of the prolate spheroid. This is prolate spheroid. Prolate spheroid obtained by revolving this ellipse about its major axis, that is known as prolate spheroid. Okay. It is given by twice pi here. Here limits are minus a to plus a. Try to understand. Into pi into ds. This is the same equation. So here minus a to plus a I can write, because why minus a? Because minus a to plus a is the major axis here. So limits are this. If I write it as 0 to a, then it will be 4 times pi, 2 into 2, 4 pi into 0 to a, y into ds. Now we have to find out what is ds here and y here. That let me calculate. So this we have to prove. Okay, let me now rub this whole ellipse. Okay, area we will calculate. Here area is given by 4 pi, in this case 0 to a, this is y into ds. That is the point. Now let me find out what is ds upon dx. Therefore ds upon dx is differentiating first this one with respect to x. So we get, what do we get here? This is twice x. Okay, or we can write it as twice x upon a square, no problem. This is twice by dy upon dx upon b square equal to 0. Or d by dx, this value is twice by into dy upon dx is equal to minus sign twice x upon a square. Now therefore this is upon b square, I'm sorry. It will be, therefore d by dx is, dy upon dx will be this value, and this is what? Okay, minus 2x, 2 to cancel out. This is minus x into b square divided by a square into y. Okay, because this b square will come in the numerator and a square is in the denominator. This is minus x into b square upon a square b square. Now d by ds, sorry, ds upon dx, which we have to find out. So ds upon dx is given by square root 1 plus dy upon dx whole square, and that is nothing but under root 1 plus dy by dx is this value. This is b4 x square upon a4 y square. Now if I substitute here value of y, then what is that? From this y square is this value that we have to put here. So let me now substitute that value. Here y square upon b square equal to 1 minus x square upon a square, or this is a square minus x square upon a square. That means y square is equal to this value. This is a square minus x square upon a square into b square upon a square upon this value. So this we have to substitute in this. D by dx is, therefore, sorry, ds upon dx, ds upon dx we are calculating is under root this value 1 plus this is b4 into x square. It was divided by a4 into y square is this value What is this? This is nothing but b square into a square minus x square upon a square. This one a square is cancelled out, b square is here, b square cancelled out. This a square, this is a square, b square, this is b square. Okay, so what is obtained? Let me now substitute this. It will give us, let me write here, this is nothing but 1 plus b square into x square upon a square into a square minus x square. What is value of b square? Let me just talk about it. If I substitute b square equal to that value in terms of eccentricity, because eccentricity is given here, we have to apply that eccentricity. Question number 8 is this. Okay, so we know that b square equal to a square into 1 minus e square. This is the value here. If I substitute in place of b this value, this is nothing but 1 plus b square is a square into 1 minus e square into x square as it is, divided by a square into a square minus x square. 1 a square cancelled out. It will come out in the numerator. Let me now solve it here. So ds upon dx is equal to, now this a square minus x square will come in the numerator as LCM. Okay, so plus, here it is now x square minus e square into x square. If I multiply by x square into 1 minus e square, then these two terms will come out upon a square minus x square. Here x square is cancelled out. Okay, so that is the value. Now let me just substitute this value. Therefore, area that we were calculating, this was 4 into pi with minus 8 to plus 8 was, it was 4 into pi 0 to a, okay, into y into ds, we were putting this ds upon dx into dx. So it is nothing but 4 pi. Now in this case y, so y was 0 to a, this value of y was, okay, b upon a, let me take outside, under root a square minus x square into ds upon dx is this value, which is nothing but a square under the square root, a square minus e square into x square, okay, divided by under root a square minus x square. So this under root a square minus x square cancels out. Now this b upon a will take outside, is 4 pi into b upon a. B upon a are taken out, and this only value left 0 to a. Under root this is a square minus e square into x square. Okay, if I take e square out, then e will come here. That means, let me put it here. So therefore, a is equal to, we are calculating the area, the 4 pi into b into e. I have taken this e square, I will take out of the square root, that way is upon a. Okay, now what is the leftover term value? This is square root, is nothing but a square upon e square minus x square. Try to understand. This is a upon e whole square or a square upon e square, because e square are taken out from this x, which was multiplication of x here, into dx. Okay, now let me solve it. Then the answer will be, let me check what answer comes out to be. Okay, so it will give us 4 pi b into e upon a. Integration of this, we know about a square minus x square. What is integration of this? This is nothing but 1/2 this, okay, x here, under root this whole value, a square upon e square minus x square, plus 1/2 into a square, means a square upon e square. this a square into sine inverse. Sine inverse will be x upon a upon e, that means e x upon a. Okay, now this is limit 0 to a. So the final answer, let me check it. 4 pi into e, 4 pi b into e upon a. Now this is 1.2, 1.2, let me take out. This is twice here. Only x, let me still write it. A upon e whole square minus x square. This is minus x square plus 1.2 I've taken out, and this is a square. Okay, a square upon e square into sine inverse. This is e x upon a. Now 0 to a limit. 0 to a. Now I have to substitute the limit. What does the limit say? Let me now check it. So finally, what is the answer of this? Therefore, area we are calculating, which is 4 into this 2 to 2 4 2 to the 4, so this is 2 pi into b into e upon a only. Okay, now inside, if I put the a back, this is a. So a into under root, it will be a square. Inside the value will be a square, the first step. This is a square upon e square minus a square. Alright, at e. At 0 it will be 0 because 0 into something 0. At 0, this is sine inverse 0 is 0, so lower limit will make it 0. Now plus sign. This is a square upon e square into sine inverse. Now e a upon e, that means sine inverse e only. Okay, now this is, if I take e and a square also, a upon e will come out. Then this is twice pi into be upon a. If I take LCM of this is e will come out. This is a square, because a from inside will come out. It will be under root 1 minus e square only left over after taking LCM. Upon e it will be plus this is a square upon e square into sine inverse e only. Okay, now if I multiply by e, which is outside, what's outside here? This e, if I multiply inside, this e will be cancelled out. This a square let me take out. This a square, and in the denominator we have a. We will get twice pi into a, because a square will come out. So this a and a square, only a is left over. A into b, pi a b. B is already there. This a will also come out. This e, if I multiply inside, so this e cancel out. Under root 1 minus e square only left, because a square are taken out, common. Okay, that a square and upon a, that means a here. So twice pi ab under root 1 minus e square plus this is only, sorry, sine inverse upon, because a square are taken out, this is sine inverse e upon 1 e left, because I multiply by e inside. This is e square in the denominator, only 1 e will be left. E here is eccentricity of the ellipse. Okay, so that is the answer. This is twice into, this is equal to 2 into area of the ellipse. Area of the ellipse is pi ab. Twice into pi ab, this is area of the ellipse. In the bracket, this is 1 minus e square plus sine inverse e upon e. So this is the answer. This is area of the ellipse. So question sums it 2 into area of the ellipse. Area of the ellipse I wrote down initially. This is pi a into b. This is area of the ellipse. The same answer is proved. So hence it is proved. This is the same answer we have obtained. Okay, question number this. Now let me talk about next question. Now question number 8. What does it say? Let me check it. Now question number 8. Question number 8 is, it says, find the area of the surface formed by the revolution of the ellipse x square plus 4y square. Here ellipse with x square plus 4y square equal to 16. This is first equation. Or if I divide by 16, it will be x square upon 16 plus y square upon 4 equal to 1. This is the equation of the ellipse here. This is first equation. Or this. So I have just changed this into proper form. Now if I compare this, here a is equal to 4. If I comparing this with x square upon a square plus y square upon b square, which is the standard form of the ellipse. So here a is equal to 4 because this is 4 square, 16 is 4 square, and b is 2 because this is 2 square 4. So a and b are this. So this is the point here. Now what is 8th question? Say find the area of the surface formed by the revolution of the ellipse x square plus 4y square equal to 16 about major axis and minor axis. So second point, minor axis. About major axis we just calculated in question number 8th. Sorry, 7th one. This question 7th, it was about major axis. Now same answer will be there, but instead of this 2 into area, so let me find the solution. So first answer let me calculate easily because we have just done in the question number 7. Now area of the surface generated by revolution of ellipse around or about its major axis. We have just calculated in question number 7. In the same way, we will just substitute there a and b. A and b are these values of the ellipse about its major axis. About its major axis is given by 2 into pi ab, 2 into pi into a into b within bracket under root 1 minus e square plus sine